Okay, chemistry kids, this video we're going to go over, we're going to begin with 1-1 and 1-2 on your visible learning document. It's really, this lesson, this is just going to be a quick lesson in case you missed it, in case you were overwhelmed on the first day of school and it went over your head, or you weren't paying attention. Because we do start off with measurement in significant figures, and that can be kind of, we're very nitpicky about it, right? So it's very detailed oriented, and there's rules that you got to remember. There's rules that you got to memorize, right? So we went over the rules in class on the first day, and hopefully it clicked with you. But if it didn't, you have this video to watch. I'm sure if you just watch videos on significant, if you just Google or go to YouTube and type in significant figures, you'll get plenty of videos explaining to you, what they are. Okay, so we're starting with measurement and we're starting with significant figures. They go hand in hand with each other. This video is going to focus on just basically what is a significant figure. So a little bit of measurement talk, so a little bit of 1-1 talk, but it's really going to be 1-2. And that really, I know it's kind of out of order, but the Schoology assessment you should try to work on first probably is the 1-2 assessment, the Sig Fig one, okay? Based on this lesson and based on, what we did on the first day of school. But you could probably do some of the measurement stuff too, because we did talk about that in class. Okay, so just kind of follow along with me, and we will get into it. So also a handout that you might want to have out while you're watching this video is the significant figures notes that you got on the first day. So I'll show you what that one looks like here in a second. So let's get into it. All right, so the Sig Fig doc is this one, significant figures. It's also called digits. So you're going to hear me say Sig Fig, you're going to hear me say Sig Dig. It's the same thing. Sig Fig, significant figure. Sig Dig, significant digit. I use them interchangeably. So does everyone else. So, when you hear it the different ways, don't let it bother you. It means the same thing. Okay? All right, so let's talk about it a little bit. All right, and if you recall what I'm about to say right now, it's what we talked about in class. So let's get into it. All right, so first let's understand a measurement is a number and a unit, right? So you have to have a magnitude and you have to have a dimension, right? So magnitude, number, dimension is a unit. The word dimension is another word for unit. Okay, so centimeter, milligram, those are all, units. Mile, yard, people, 5 people in the room. That would be a measurement, right? You got 5 and you got unit people, right? So you got to have, a number, but you have to have something that's describing the number, and we call that a unit or dimension. All right. Now, we use analog devices to measure things, and we use electronic things. So like we use digital thermometers, we use digital balances, right? So we don't really have to look at the calibrations, look at the tick marks to measure those. But then also we'll use graduated cylinders. They have tick marks. We don't really use rulers in chemistry that much, but we use them as an example of how to take a proper measurement. So let's talk about it. So if I'm using a ruler, or maybe I'm using a graduated cylinder, right? Graduations are those tick marks, okay? Calibrations, all right? And taking a proper measurement depends on what types of calibrations I'm given, okay? What precision do they have, all right? So let's look at this, right? If you can see, I'll zoom in on it, all right? So if we look at the graduated cylinder, if I want to take a proper measurement, I would want to make sure I know what each calibration represents. So this is milliliters, right? So this is a milliliter graduated cylinder. And so 5, that means 5 milliliters, right? 10 means 10 milliliters. But let's look at all the smaller tick marks here. So, right, it would be 1, 2, 3, 4, 5. So in between 5 and 10, 6. So each tick mark represents 1 milliliter, right? So the calibrations or the graduations of the graduated cylinder get me ones. They go up by ones, right? So look at this, look at where the meniscus is, right? The bottom of the meniscus. It's right in between 21 and 22, right? So what should I report? Should I say 21? Should I say 22? Should I say somewhere in between? You know, what am I supposed to do? All right. Well, let's say I thought it was right there in between, right? I might say 21.5, and that's a perfectly good measurement. But you might look at that and say, well, no, I think it's a little bit above 21.5, so I said 21.6, right? Or maybe you looked at it and you thought it was a little bit below 21.5, so you said 21.4. Which ones of these are right? The answer is all of them, okay? Right? So the graduating cylinder gets me in between 21 and 22, so I know it's somewhere in between there. But that next digit, right? The 5 here, the 6 here, the 4 here, that's called an estimated digit. And whenever you take a measurement with something with graduations, you have to have an estimated digit. But it's an estimated digit, meaning my estimated digit might be different from yours. So we're certain that it's 21 point something. And we know it's not 22. We know it's below 22. So I know it's in between 21 and 22. So it's 21 point something. But that whatever that something is, that's up to the person taking the measurement, right? Right? So how do I know how many decimal places to go to? Well, if I'm given the ones place, which I'm given in this graduated cylinder, then I can estimate to the tenths place. Okay, so I'm allowed to estimate the tenths place, but I'm not allowed to estimate to the hundredths place. So again, these three measurements would all be perfectly fine based on this picture. You know, if this is what you were looking at in the lab, these would be perfectly fine measurements. Okay, but what I couldn't do is I couldn't say 21.50, right, or 21.51 or 21.595, right? That's too much estimation, right? The precision of the instrument, the graduations, don't give me enough to go that far. So I could say 21.5. This is a correct measurement. This would be an incorrect measurement, even though they have the same exact value, right? 21.5 and 21.50, those numbers have the same exact value. But when we're talking about measurements, they mean different things. It's about significant figures, okay? And we'll talk about that. And I'll show you why it's important here in a second, all right? So I wouldn't be able to say that stuff, all right? That would be an improper measurement based on this graduated cylinder. None of my measurements should be to the hundredths place because the calibrations don't get me to that point. I can't do it, all right? But let's say it fell right on the line. Let's say the meniscus was right there, right on the line, right at 21. If you just wrote 21, that would be an improper measurement because you're allowed 21.0. Now you're not allowed 21.00, but you're allowed that estimated digit. And so if you're allowed it, you need to take it. So just saying 21, like again, if the meniscus was down here a little bit lower, right? If it was right on the money, right on that line, I could say 21, but I'd have to report it as 21.0, all right? Okay, if you just wrote 21 milliliters, you're shortchanging yourself based on the precision of the instrument. You're allowed 21.0, but you just said 21. And that's gonna be a big difference when we talk about significant figures here in a second, okay? All right, but let's just do it in more practice. Now, if this is a 10 milliliter graduated cylinder, and if you look at these graduations, this big line right here, that's 6 and that's 7. So we got all these tick marks in between, these graduations in between. So notice that each one of these marks represent 0.1 milliliters. If we went back up here, each one of the smallest marks here represented 1, but each of these represent 0.1. So the calibrations of this graduation, of these graduations, right, of this graduated cylinder, give me the tenths place. So that means I have to estimate to the hundredths place. So here's a graduated cylinder where I'm allowed to measure to the hundredths place. I can't go beyond that. I can't go to the thousandths place. And I shouldn't stop at the tenths place. All right, so let's look at the meniscus. The meniscus looks like it's right there, right on 6.3. So this would be 6, 6.1, 6.2, 6.3. And if you look at the bottom of the meniscus there, it might be slightly above 6.3, or some of you might estimate that it's right at 6.3. So if I thought it was right at 6.3 and I just said 6.3, I'm shortchanging myself. I'm allowed to have the 0 because the tick marks get me to the 10th place. I have to estimate to the 100th place. Okay? So again, 6.3 wouldn't be a valid measurement here. I'd have to say 6.30. Now, somebody else might look at it and say 6.31. That's perfectly fine. All right? Somebody else might even say 6.32. Okay? But I need that estimated digit. So even if that estimated digit is a 0, because it falls right on the calibration mark, right on the graduation, if you're allowed an estimated digit, you need to take it. So this graduated cylinder gets me to the 100th place, whereas this graduated cylinder only gets me to the 10th place. Okay, and it's based on what the smallest calibration or the smallest graduation on whatever you're using to measure. The same rule applies if you're using a ruler. Anything that has graduations, anything that has calibrations, anything that has tick marks. Okay. Okay. So why does this matter? Okay. So let's think about it, right? What if I wanted to figure out the density of something, right? Hopefully we understand what density is. But if you don't, density is the ratio of mass to volume. So what do you need to do? You need to take mass of the object, you need to take volume of the object, and you need to do mass divided by the volume, and that gives you the density. So if I said, hey, here's something, go get me the density of it, you'd have to take two measurements. You'd have to go in the lab and you'd have to measure that object's mass and you'd have to measure that object's volume. Okay? Well, to measure mass, I'm going to use a balance. To measure volume, I'm probably going to use a graduated cylinder and water displacement. Okay? And we'll talk about those techniques. Okay? But I need to get those two measurements. So I need a mass measurement, so grams probably. And I'm going to need a volume measurement, so liters, maybe milliliters, probably milliliters if I'm using a graduated cylinder. But a volume, gallons of volume. But I need a mass measurement and I need a volume measurement, okay? So you go into lab and you get this as your mass measurement, right? Let's say you use a digital balance and you put the thing on the balance and it reads 3.20 grams. And that's what it reads, 3.20. So you write that down. That's your mass measurement right there, right? You use a 25 mil graduated cylinder like this one, right? So you're only allowed to estimate to the 10th place. And so this is the measurement you get for the object's volume, all right? So those are the measurements I get. And now if I want to report the density, all I have to do is the mass divided by the volume. So this number divided by that number. So I break out my calculator, my trusty calculator, and I write 3.20 divided by 6.2, enter, and this is what my calculator spits out. When I take 3.2 and I divide it by 6.2, this is what I get, right? That's a lot of digits there, okay? And the units would be grams divided by milliliters. The way we write that is grams per milliliter, right? So that would be my unit. That is an example of a unit of density, okay? Great. So is this what I should report the density as? Should I say, so you come back to me, I said, hey, go measure this substance's density, and you come back to me and you say, okay, we measured its density and we got it that it's 0.516129032258 grams per milliliter. What? No, you can't report that. You can't report that, right? Why? Because the measurements you used to get that value for the density only had this certainty. This measurement had to the 100th place. This measurement had to the 10th place. So how are you going to be certain to whatever place this is? I don't even know what it's called, right? We got the 10th place, the 100th place, the 1000th place, the 10,000th place, the 100,000th place, the millionths, and then I don't know. So like I can't report that because you can't be certain of that many decimal places. Now maybe if this was my measurement for mass and that's what the digital balance precision went to, and then this was my measurement for volume, I'm not going to add a million zeros here, then yeah, I'm pretty certain that that's the density. But no, that's not what I got. I got this measurement for volume. Oops, need my unit there. And I got this measurement for density, or for mass. You know? So I can't report that. So what do I have to report? This is what I would have to round my answer to. So that's what my calculator says, but based on the measurements I used, I'd have to say 0.52 grams per milliliter. Okay, so the reason that is because this measurement or this answer has two, what we call two significant figures. Whereas if we go up here, right, the measurements I used to get that answer, this number has 3 sig figs, this number has 2. So the rule is when you multiply or divide measurements, you have to round your answer to the least number of sig figs of the measurements you were using. So again, this measurement had 3 sig figs, this measurement had 2. So when I take this measurement and I divide it by that measurement, I have to round my final answer to 2 sig figs. So that's why I had to round to here. So again, if we go back up to what the calculator said, 0.516, but I know I only need 2 sig figs. So I go to my first 2 sig figs, 0.51, those are my 2 significant figures there, and then I would use the third to round up or down. So 6 rounds up to 2, 6 rounds the 1 up to 2, so that's why it's 0.52. So that's what I would have to report. Again, I got my measurements, I put them in my calculator, this is what I get, but that's not what I can write down. That's not what I can report. I got to switch it to here, okay? So, and again, it's all about reporting ethical numbers, right? You can't be certain that this is the density using the instruments that gave you these measurements, because these measurements aren't that certain. And this measurement is really certain. But you got this measurement based on those measurements. So you can't use measurements to get another measurement, like using mass and volume to get density. And the density that you report can't have more accuracy or precision than the measurements you used to get that. Okay? So it comes down to significant figures, right? So that's the first thing we need to be able to do. All right, so we have to be able to look at measurements, look at numbers, and say, okay, this number has this many sig figs, this number has that many. Because again, I had to be able to look at this and know that this number has 3 sig figs, and this number has 2 sig figs. And the reason I had to do that is figure out what did I need to round this number to? 3 sig figs or 2 sig figs? I got to go with the lowest one. So I had to round this number to 2 sig figs because this measurement had 2. Well, how do I know that measurement has 2 sig figs? Well, I know what a significant figure is, and that's why, and so you have to, right? All right. So pretty easy if it's non-zero. If it's a non-zero digit, it's significant. Okay? Boom. So it really just comes down to the zeros. And so you got to remember these rules. We got 3 types of zeros. We got leading zeros. There's zeros on the left side of the number. So these would all be leading zeros here. This would be like this number is 165, and I wrote 3 zeros in front of it. I don't need them there, but that's a leading zero. Like these 3 zeros would be leading zeros. These would be leading zeros. Doesn't matter if there's a decimal place. If there's no other non-zero digits to the left, the zeros that are all the way to the left, these are leading zeros. Then we have captive zeros or sandwich zeros. So they're in between 2 non-zero digits. So these zeros are in between those non-zeros. This is a captive zero. These are captive zeros. It doesn't matter how big the sandwich is. These are all captive zeros, right? And then we have the zeros on the right side. So we call them trailing zeros. So these 2 zeros trailing in the number 100, those are 2 trailing zeros. And the number 1 million, or sorry, 1 billion. These would all be trailing zeros. Okay, so it's pretty easy. The rules are leading zeros are never significant. So these zeros right here, not significant. These zeros right here, not significant. Okay, leading zeros never significant. That's the rule for leading zeros. Captive zeros always significant. So these zeros right here, they're captive, significant. This zero right here, captive, significant. These zeros right here, they're captive, so they're significant. Okay, so these zeros right here, not, because they're leading. Leadings are never. Captive are always, so all these zeros right here would be significant. And trailings are the if, all right? So if we have a never and we have an always, well, and we have a third rule, well, I guess it's they are sometimes and they aren't sometimes. So if the decimal point is actually written in the number, trailing zeros are significant. If the decimal point was not written down on the piece of paper that you're looking at, then the trailing zeros are not significant. So let me show you what I mean by that, right? So let me give you an example. Okay, so let's look at this. This is 100 and that's 100, right? No difference in this, the value of this number, 100. This number, 100. But this 100 written this way is 1 sig fig. 100 written this way is 3 sig figs. Why? Because this 100 doesn't have the decimal point written. So those two zeros are trailing zeros. They're not significant. So only the 1 is significant here. But then this number, they're trailing zeros and the decimal point is written, so they are significant. So the 1's significant, but these two zeros are also significant because we wrote the decimal point. So 3 sig figs. So this is 100 with 1 sig fig. This is 100 with 3 sig figs because I wrote the decimal. Okay. I could do 100 with 4 sig figs. I just do another trailing zero. Here's 100 with 3 trailing zeros. The decimal point is written. So that would be 4 sig figs. All right. So let's look at it. So this number, the way it's written, only has 1 sig fig because these are leading zeros. So it's just that digit is significant. So here, all the digits are significant because we would define these zeros as sandwich zeros or captive zeros. Whoops, just trying to highlight the zeros here. Between 1 and 8. So 1 and 8 are significant, and then the zeros between there would also be significant. Okay? And then if we go here, these zeros, not significant because they're leading, but these zeros would be significant because they are trailing zeros and the decimal point is written. So the 2 is significant, and then these two zeros are significant, so 3 sig figs. Okay? And then we're going to use a lot of scientific notation in this class. And so numbers written in scientific notation, just whatever's in front of the multiplication sign is significant. So this has 3 sig figs. All right? Now notice here is 100 written 3 different ways. 1 times 10 to the 2 is 100. 1.0 times 10 to the 2 is also 100, and 1.00 times 10 to the 2 is also 100. So there's no difference in the values of these numbers, but this would be with 1 sig fig, because I only have 1 digit written here. If I wanted to add a sig dig, I could go 1.0 times 10 to the 2, that's 2 sig figs, and then 1.00 times 10 to the 2, that would be 3 sig figs. And then we got 4 sig figs here. Okay? So that's the rule. Okay, and then when you're doing math with these measurements, whoops, let me go to here. Okay, when you're doing math with the measurements, when you're multiplying or dividing, like we found the density, right? You have to limit yourself to the least number of sig figs. So let's look at this example on your note handout, right? We're doing centimeters times centimeters times centimeters. And so my unit would be centimeter cubed, right? But when I multiply this by this by this measurement has 4 sig figs. So whatever I use to measure this length, I could go to the hundredths place. But then whatever I use to measure this length, I couldn't even estimate to the tenths place, right? And then here I could go, whatever I use to make this measurement, I could go to the thousandths place. So now when I take those 3 different measurements and I multiply them by each other, this is what my calculator gives me. But that's not what I can report as our volume, right? Length times width times height. I can't report that as my final measurement. This number only has 1 sig fig. This number has 4 sig figs, this number has 4 sig figs, but this distance that I measured only has 1. So I have to take what the calculator gave me and round it to 1 sig fig. So how do I round that to 1 sig fig? So I go to the first significant digit from left to right, and then I use the second one to round up or down. So 2, and then 5 rounds the 2 up to 3, and then 300. So remember, these zeros are not considered significant, right? Because they're trailing, but I didn't write the decimal. So here is 300 centimeters cubed, and I had to round to 1 sig fig because that measurement right here only had 1 sig fig. All right. Now the rule for adding or subtracting is slightly different. It's not about sig figs, it's about decimal places. So here we're adding measurements together. Okay. And when you add, you have to limit yourself by using decimal places. So this distant measurement had 2 decimal places, this only had 1, this had 4 decimal places, but notice that this one had 0 decimal places. So when I add them in my calculator, this is what I get, but I can't report that because of this measurement here. It doesn't have any decimal places, so I have to round my final answer to 0 decimal places. So this is what I would have to report. Okay, so there's a rule if you're adding or subtracting measurements, it's the decimal place rule. And then there's the rule if you're multiplying or dividing measurements, and that's the sig fig rule. Okay. And again, we'll do a lot of practice with this, but that's just kind of a brief overview of what we kind of discussed in class on the first day. All right. In terms of, actual chemistry content. All right. So hopefully the video helps you out a little bit. Hopefully you didn't need the video. All right. So good luck on your assessments as you're working on them. And I'll see you next time.